How is time related to Newton's second law? According to Newton's second law, acceleration is produced when a force acts on a mass. The greater the mass of an object being accelerated, the greater the amount of force needed to accelerate that object. For example, if we have a car, it will take a greater amount of force to move it a certain distance compared to the force needed to move a small soccer ball. The second law gives us the exact relationship between force, mass, and acceleration. This can be expressed as a mathematical equation. Force equals mass times acceleration. We know that acceleration is the same as the change in velocity over the change in time. Here we can substitute delta v over delta t for a in this other equation. So that means that force equals mass times delta v over delta t. If we want to get rid of delta t as a denominator, we multiply both sides of the equation by t over 1. The delta t's will cancel out and we will be left with force times the change in time is equal to the mass times the change in velocity. We measure this in newtons per second. This, the force times the change in time, is what we call impulse. Impulse causes a change in velocity. Newton called the product of mass and velocity momentum. Momentum in equations is symbolized with the variable p because m is used for mass. For an object in any particular moment, the momentum is found as p equals m times v, where m is mass in kilograms and v is velocity in meters per second. Momentum can change from second to second as an object accelerates or decelerates. This means that delta p is equal to the mass times delta v. This can be combined with impulse to give us the set of related variables. Any other one corner of the triangle can be used to find information in another.